Okay, so I really like this question because it lets us see how logarithms work and why they exist where they exist. So we're trying to figure out, by using the power law, do you guys remember that power law? Okay, this right here. Okay, that logarithm with argument x to the power of n is equivalent to n times the logarithm argument x. Okay, just taking that exponent and making it a coefficient. We're just going to study if those graphs actually look the same. And there's two cases to tell if they're the same or not. There's an odd case and there's an even case. So let's just look at the odd case to start. By odd, they're talking about the value of n. So if we looked at the value of n equals 3, that would change the graph to log x to the power of 3. And if you want, you can graph that along with me. So in your y equals, you're going to go log, and then x to the power of 3. And then hit graph when you're ready. Now, say we didn't have our calculator, we would have to use a table of values to figure out where this graph exists. And I'm just going to shortcut by going to the table of values on your calculator. So second table. And do you guys see when x is a negative value, how we have
junior class change,
all these errors coming up? So I'm just going to explain why that happens. And I'll create a table of values here so we can go through it as well. Okay, let's say that x is negative 3 and we're subbing a negative 3 into that logarithm. Okay, y will equal log negative 3 to the power of 3. That equals logarithm negative 27. Do you guys remember whether we can take negative logarithms or not? So we can't. And the reason why, I'll show you over here. Okay, let's say we had y equals logarithm base 10 to negative 27, like we had there. And we tried to put that in exponential form. So we have 10 to the power of y is equal to negative 27. Is there anything we can raise 10 to? So 10 to the power of anything, that will give us a negative number. No. Okay? And that's going to occur every single time. There's nothing we could raise a positive number to get a negative number. So that's why negative values do not exist for logarithms. So that would be true for negative 2, for negative 1, and then I'm going to go through the example of 0 as well. Okay, so we have an error. For negative 3, for negative 2 we have an error, for negative 1 we have an error. Okay, why do we have an error at 0? Let's test it. Y will equal log 0 cubed.